As Chandrayaan-3 propels India to become the first nation to land on the lunar South Pole, there is an immense opportunity to uncover more about the moon's geological history, composition, and potential for scientific discovery. But why has the moon captivated human curiosity for centuries? The moon is estimated to be about 4.5 billion years old, that is, around the same age as Earth. The most popular theory about the moon's formation suggests that a Mars-sized celestial body collided with a young Earth. The Apollo missions brought back rock and soil from the moon, which provided some clues on how the moon may have formed. The rock showed that the Earth and the moon have some remarkable chemical and isotopic similarities, suggesting that they have a linked history. The lunar South Pole has become the focus for exploration due to its unique features and potential scientific value. According to NASA, the moon's South Pole is full of mystery, science, and intrigue. The deep craters in the lunar South Pole have been shielded from sunlight for billions of years. The moon's axis is only slightly tilted relative to its orbit around the Earth, and as a result, certain areas near the poles being in permanent shadow. These shadows create extremely cold environments. Temperatures here can plummet to as low as -248 degrees Celsius. It's no wonder that no human has stepped foot on the lunar South Pole. But these frigid conditions have helped preserve water ice for billions of years. Yes, the lunar South Pole is believed to host a vast reservoir of water ice in the permanently shadowed regions. The frozen water, untainted by the sun's radiation, might have accumulated in cold polar regions over millions of years, and this has led to the accumulation of ice on or near the surface. This provides a unique opportunity for scientists to analyze and understand the history of water in our solar system. The presence of water is also of immense significance for future space exploration. So how exactly did scientists find water on the moon? As early as the 1960s, before the first Apollo landing, scientists had speculated that water could exist on the moon. But in 2008, it was India's Chandrayaan-1 lunar mission which was the first to find evidence of water on the moon. Data from Chandrayaan-1 indicated the presence of water molecules in the permanently shadowed regions. This discovery has opened up exciting possibilities for sustained lunar exploration. If water ice exists in sufficient quantities, it could be a source of drinking water for moon exploration and could help cool equipment. It could also be broken down to produce hydrogen for fuel and oxygen to breathe. Water ice is a critical resource for the future lunar exploration and even beyond. It can be converted into breathable air, drinking water, and most importantly, hydrogen and oxygen for rocket fuel. This could revolutionize space travel by reducing the need to transport these resources from Earth, thereby making long-duration missions more feasible. Many countries are planning new human missions to the moon, and the astronauts will need water for drinking and sanitation. Russia and China have plans to build a lunar space station to develop research facilities on the surface of the moon. Despite the failure of N18V, Russians are planning more lunar missions. NASA is sending instruments on commercial landers to go to places across the moon. Japan is preparing to send a smart lander to demonstrate accurate lunar landing techniques by a small explorer. And there is NASA's Artemis program, which aims to put astronauts back on the moon more than half a century after the last Apollo mission. That's why the world's eyes are on India's Chandrayaan-3. One small step will be a giant leap for mankind.